When 15 spacecraft across the solar system suddenly turned toward a single object from another star, it wasn't curiosity. It looked like urgency. The moment NASA released the complete 3-eye atlas image gallery, something shifted. Not outside, not in the sky, but inside the people who study it. When the gallery went live, I didn't lean in, I didn't zoom, I didn't even scroll. I just stared. Seconds passed, then minutes. I wasn't frozen from fear, it was realization. For the first time in the history of space exploration, 15 spacecraft across the solar system, from orbiters to deep space probes, turned toward the same interstellar visitor. Hubble, Webb, Lucy, solar observatories, Mars missions, all redirecting their eyes toward a single object drifting in from another star. Nothing like this had ever happened for Oumuamua. Not for Borisov, not for any comet, asteroid, or mysterious transient caught wandering through our system. This wasn't routine. This wasn't curiosity. This looked like urgency. NASA has coordinated multi-mission observations before, but never like this. Not with this many instruments, not with this many angles, and definitely not with this much coordination. When NASA activates 1 or 2 spacecraft to track something, that's normal. But 15, Mars rovers, solar physics satellites, infrared surveyors, ultraviolet imagers, deep space explorers, all participating in a synchronized tracking effort, that's a signal. Something about 3-eye atlas didn't just interest NASA, it compelled them. And the more images that came in, the stranger the object appeared. One spacecraft showed an intense brightness, another showed a shifting structure, another revealed tail directions that defied expectations. Every instrument saw something different, as if the object wasn't presenting one identity but several. What kind of interstellar visitor looks different from every angle? What kind of object refuses to settle into a pattern? When NASA published the gallery, the list of observers read less like a technical appendix and more like a lineup assembled for a once-in-a-generation event. Hubble contributed its piercing morphology shots. James Webb added its infrared chemistry. SphereX mapped the thermal behavior. MAVEN traced the ultraviolet halo. The Mars Reconnaissance Orbiter, along with HiRISE, captured the geometry of the dust envelope. Punch watched the solar interaction. Perseverance recorded changes from the Martian surface. Lucy measured brightness from deep space. And it didn't stop there. SOHO, Stereo, Europa Clipper, Parker Solar Probe, Psyche. A constellation of missions, each turning away from its usual duties. This level of coordination is normally reserved for planetary targets, not for something merely passing through. NASA only mobilizes like this when an object isn't just noteworthy, but potentially transformational. 3-eye atlas earned that response within days. Local comets behave like seasoned performers. Their tails drift in predictable arcs. Their brightness evolves along well-modeled curves. Their comae swell and fade in the slow, familiar rhythm of sublimation. Everything follows patterns we've known for decades. 3-eye atlas did none of that. Its tail shifted direction far too abruptly. Its coma expanded, contracted, and expanded again without warning. The nucleus brightened in ways that couldn't be linked to sunlight or distance. The dust envelope thickened into a smooth, symmetric shell, a shape far too orderly for the chaotic material that usually erupts from a comet's surface. Every frame challenged the idea that this was a routine, icy wanderer. And those contradictions were only the first cracks in a mystery that grew deeper with every new image. When the Hubble frame appeared in the gallery, it marked the moment many scientists quietly realized they were looking at something unprecedented. The object didn't show the familiar triangular tail of dust pushed by sunlight. Instead, the image revealed a blue, teardrop-shaped cocoon that was unnervingly smooth, strikingly symmetrical, and wrapped around a luminous core. That kind of symmetry has no place in natural comet behavior. Comets shed dust unevenly. Asteroids lose material in chaotic bursts. Nothing in our solar system produces a shell this clean, this cohesive. The image hinted at a different kind of structure, something that behaved less like a loose collection of ice and rock, and more like a body with its own internal order. The nucleus appeared intact even at Mars's distance. The dust clung close instead of dispersing into sunlight. The outgassing was gentle and steady, not fragmented or explosive, and the coloration suggested minerals and grain properties rarely seen in local comets. Hubble wasn't showing a delicate object disintegrating as it approached warmth. It was showing something tougher, shaped by conditions we don't encounter in our neighborhood of the galaxy. A visitor whose resilience immediately raised questions. Then came Maven's ultraviolet view, the most shocking result for anyone who studies comet halos. Instead of a tight cloud of gas near the nucleus, Maven found a gigantic hydrogen halo extending far beyond what models allowed. The halo was so large it had only one explanation: extreme water dissociation. Ultraviolet light only creates hydrogen atoms by breaking apart water molecules. So if hydrogen appears at that scale, the object isn't gently leaking water. It's releasing massive amounts of it. And here's the problem. It was doing this far from the sun, at a distance where most comets remain frozen solid. There are only 3 explanations, and all are fascinating: internal heat, exotic chemistry, or an insulating crust enabling controlled venting. Each possibility points to an object shaped outside our solar system, possibly in an environment far more extreme. The Mars Reconnaissance Orbiter brought another revelation. HiRISE didn't see a point-like dot. It captured a clear white semicircle, a translucent veil of dust forming an unexpected symmetry. That shape revealed 2 important truths. The nucleus is physically large, likely kilometers across, and the dust envelope is thicker on one side, indicating one-directional heating. Comets typically form tails. 3I Atlas formed an orb. Even from nearly 900 miles above the object, the dust remained visible. Whatever was happening, it involved scale, density, and symmetry, unlike any comet we have cataloged. Punch delivered one of the most subtle but alarming clues. The tail didn't point directly away from the sun. That defies basic solar wind physics. Comet tails should follow the pressure stream like flags in the wind. Instead, Punch photographed a faint tail angled sideways, inconsistent with expected forces. There are 2 scientific explanations: local solar wind variability, meaning the wind changed direction, or asymmetric jets causing non-gravitational acceleration. The second explanation is the one that unsettles scientists because it mirrors the unexplained acceleration of Oumuamua. This does not suggest artificial propulsion, only unfamiliar physics. But unfamiliar physics is enough. Psyche watched 3I Atlas for 8 uninterrupted hours. During that time, the object drifted across the starfield in a subtly irregular path. The deviations were tiny, almost imperceptible but measurable. And measurability matters. Every interstellar object so far has shown some deviation from pure gravity. 3I Atlas followed the pattern, behaving as if guided by internal forces we haven't yet mapped. SphereX added another layer to the puzzle with its detection of an unexpectedly bright thermal core. The interior of 3I Atlas appeared warm, far warmer than an object wandering the deep cold of interstellar space should be. That warmth pointed to possibilities none of them were standard. Radiogenic materials releasing heat over unimaginable timescales, pressurized gases trapped beneath a crust, or perhaps a surface so dark and efficient at absorbing sunlight that heat accumulated in ways we don't commonly see. Whatever the explanation, the implications were the same. 3I Atlas likely had layers: a crust, internal pockets, or a complex interior structure that preserved heat long after it should have dissipated. For something that had traveled between stars for millions, maybe billions of years, carrying that warmth made no sense, unless the object was composed of materials or shaped by processes unfamiliar to our system. Lucy viewed the object from nearly the opposite position as Earth. If the object were rough, uneven, or scattering light badly, brightness should have shifted dramatically. But it didn't. Lucy and Earth-based angles showed similar brightness, hinting at either a high albedo nucleus or dust grains with highly reflective properties. Again, uncommon. Again, unexplained. SOHO barely captured the object at all. In visible wavelengths, 3I Atlas appeared as a faint yellowish dot, almost invisible in noise. But in infrared and ultraviolet, it was bright, structured, complex. Why would an object reflect so poorly in visible light but radiate strongly in other wavelengths? It could be surface composition, unusual materials or grains unlike the ones found in local comets. Individually, each spacecraft told only a fragment of the story. Hubble showed a teardrop cocoon. Maven showed a massive hydrogen halo. MRO revealed a semicircle of dust. Punch showed a tail breaking the rules. Psyche recorded trajectory deviations. SphereX detected a warm core. Webb measured unusual chemistry. SOHO showed dim visible reflection. Lucy observed deep space brightness. Perseverance sensed faint dust. Stereo captured vertical stripes. Atlas provided the first point source detection. Taken together, the pattern becomes undeniable. 3I Atlas is not behaving like a typical comet. It is something shaped by natural processes we have not observed before. The combined gallery is more than a scientific archive. It feels like a message carved into dust and ice long before humanity existed. For billions of years, 3I Atlas drifted through interstellar darkness unnoticed. For a brief moment, it passed close enough for us to see it, study it, and question it. NASA didn't release a set of pretty pictures. They released the first attempt at understanding a visitor shaped by conditions outside our solar neighborhood. Whether it is a fragment of a distant planet, a shard of an exomoon, or simply a comet built from chemistry unlike our own, it offers the one thing science needs most: a clue. And that is why this gallery matters. Scientists will debate this object for years. They'll argue about its crust, its halo, its heat, its tail, its symmetry, its composition, and the strange irregularities in its motion. But the truth is simple. 3I Atlas is unlike any interstellar visitor we've ever seen, and humanity almost missed it. The gallery is our only chance to decode what it is, or what it once was, before it disappears back into the dark.